this your first class today? Yeah. Or did you have class?
Individual.
Oh yeah, that's right, yeah. Yeah. Okay, if you can take that and pass it around, that'd be great. Right. Okay. Where are we starting with? What page now to look at first?
14.
Which one?
Page 14.
14, okay. Which question?
The last two questions.
Right, so which one do you want me to do?
The second one.
Yeah, give me the question on the latter, please.
Solve 36x cubed.
Huh? Page 14, yeah?
Page 16.
Oh, 16. Oh, 4 and 5, is it?
Yeah.
Yeah, okay. Page 16, 4. Solve. Can you see? Yeah. 4x4 minus 5x squared minus 9. And my hint is that u equals x squared. Yeah? So that means that u squared equals x4. Yeah. So here I can change this into 4u squared minus 5u minus 9. So this is a quadratic with u. So u equals minus b plus or minus square root b squared minus 4ac 16 9. I know. It can be factorized? I'll let you use the formula. B squared minus 4ac, so that's 16 9, 144, 169, square root 169, 13. So it's 5 plus or minus 13 over 8? Yeah. So that will be u equals 18 over 8 or minus 8 over 8. Which is 9 over 4 or minus 1. So you have u, which is x squared. X squared equals 9 over 4 or x squared equals minus 1. Well, of course, that makes no sense. So we finish off with x equals plus or minus 3 over 2. Okay, write this down if you need to, please. Yeah?
Why don't you do factorize?
That's what he said. I don't know. I wanted to use the formula. You can factorize if you like.
Can't you just put x equals I for the other? Or that would be wrong?
X equals... no. Won't be doing that just yet. Okay. So if you can write this down, we'll have a look at number 5 in a moment. Yeah. Yep. Okay. Number 5 now. 36x4 minus 145x squared plus 144 equals 0. Now we can just, we can take a shortcut here. We can see that this is a quadratic. And we can see it's a quadratic where the x is not actually x, but it's x squared. Because if you think about it, the middle number should be x, the middle term, and it's an x squared. So it's a quadratic except it's x squared instead of x. So we have x squared equals minus b plus or minus the square root of 21025 minus whatever 144 times 144 is. Just give me a moment. 72. That's 145 plus or minus square root 8. 289. Don't tell me 72, 16 and 16. Hang on. 17, isn't it? 145 plus or minus 17 over 72. 145, 155, 165, 165 minus 3, 162 over 72. And if we minus 145, 135, 125, 127 over 72.
That's right.
It's right? Why do you sound surprised?
What's right? 127.
Is that 127? Sorry, what is it?
Right.
What?
Did you hear this?
128. Everybody's done this?
Yeah.
Great. No? An important side. 128. Do you know what's stupid? In the last class I said 127 as well. Right, so these can be simplified.
9 over 4 and 16 over 9.
9 over 4 or 16 over 9. So we have 4 answers here when we take the square root. Minus 3 over 2, plus 3 over 2, minus 4 over 3, and plus 4 over 3. They're the 4 answers. Okay, you can write that down.
So like this formula has 4 roots?
Yeah. Yeah, so if you're wondering, it would, it would look something like this.
Oh, okay, no problem.
It's like 2 of them. Finished? Thank you. Right, what do we need to see next? Have you got a pen handy? Wednesday, 3 hours. Thank you. Right, what's next? Yeah.
Can we use some page 14, number 6,
Give us a letter.
W and V?
Page 14, 6W.
And V.
Okay, so 6V and then 6W, yeah? Okay. Y equals x squared plus 2x plus 37. So y equals x plus 1 squared plus 36. So a quick sketch here. There's x, there's y, crosses the y at 37, and the vertex at minus 136, which would be like here, we'll say. And there we go. So that's 6v. And then 6w. Y equals x squared plus 18x plus 145.
They're asking for the roots too.
In some cases you can also show the roots. Not in this case. Not even close. Not even close. Y equals x plus 9 squared, that's 81, and 81, 19, 45, 55, 64. Is that right for this one? Yeah. So, again, this one also has no roots. So if I was to sketch it, x, y, that's like 145, and we can say about there 64, and we can make there about minus 9, and we can make that the vertex, so, it could be something like that. Yeah. Yeah.
I have a question. They said showing the vertex and the y-intercept.
Yeah?
Does it have to put in, like, you have to find the points exactly and like show it?
I did, yeah. I marked them in here. In the exam, you want to maybe just mark it in like this, minus 9, 64. Yeah. And here you could just mark in 0, 1, 4, 5. Like that, something like that. Yeah? Is okay? Wait, someone behind you. Yeah. Maybe it's the same question. Is it 18? The last one in number 2. Ah, yeah. A lot of people got tripped up on this one. We'll see. Page 18 to Z. Okay. X squared plus K squared plus 1. Now, to make that really clear, that's equal to 1x squared, yeah, plus 0x plus k squared plus 1. Yeah. So the discriminant is b squared minus 4ac, which is minus 4 times k squared plus 1, which is always negative. So therefore, no real roots.
But when you graph it, it resembles x squared plus 1.
What do you mean?
Like I was graphing this and then.
I don't think you really can graph it because you don't know the k. I mean, you could kind of graph it actually. It would look like this.
Yeah.
And this point here would be k squared plus 1.
Yeah. And it was that's the same formula as x squared plus 1. Like the
Yeah.
x quadratic is x squared plus 1. So
It's like this, isn't it? Yeah.
I thought that k is 0. Not k must be 0.
No. K could be any number because you could have like x squared plus 10. Same problem, yeah. Yeah. So. Yeah.
How would you be able to graph it if you don't know k? Wouldn't that be just assuming that k is 0?
No. I'm able to graph this one because it's not too difficult. Because I can see that this is the y-intercept, k squared plus 1. But I don't really have a good idea of what the shape is like because I don't know. It depends on the k. It could be quite skinny or it could be quite wide. So I just have a rough idea of the shape. Yeah.
Can you find the value of k here?
Like actually get a number value is not possible. K could still be anything. It literally could be any number. Could even be 0. Yeah. Like, if k was 0, your graph would be intercepting the y-axis at what point? At 1. If k was equal to 3, where would it intercept the y-axis?
10.
Yeah, at 10, if k was 3. So, by changing the value of k, all you can really do is move the quadratic up and down the y-axis, but you can't move it any lower than what?
1.
Yeah, you can't go any lower than 1, and that would only happen when k is 0. So, no matter what you do to the quadratic, you're always stuck a little bit too high for it to have roots. You can't cross it.
What confused me also, that after the minus z for z is 0. That's why I thought k is equal to 0.
Oh yeah, well 0 as in 0 roots.
0 roots.
Yeah, no real roots. Yeah. Okay. Who was asking for that actually? Anyways, is it okay now? Yeah. Right, so what do we need to see next, yeah?
Yeah. Can we please solve page 18, number 2, x and b?
X and B. In number 2?
Yeah. Page 18.
Yeah. X and B. Alright, let's start with B then. And which ones?
X, b, and m.
Okay, now, I understand why you're asking for this one, but why are you asking for these 2?
Because of the sign.
The signs, okay. X and B. So I will start with X. This is page 18, question 2. Right, starting with x. Minus kx squared plus k plus 4x minus 3. So the discriminant is b squared minus 4ac. Yep. Right, that is k squared plus 8k plus 16 minus is a minus 12k. Triple minus. That's equal to k squared minus 4k plus 16. That is equal to k minus 2 squared plus 12. This is always positive, never equal to 0, so it has two real roots. That is x. We shall do v now. Yeah? Scroll down? No, I see people writing, that's okay. Yeah? Number 3? Ah, so you have something after this one, okay. So, let's do v next. Can I scroll down? Yeah, okay. Minus k x squared plus 4kx minus 4k. Right, discriminant is b squared minus 4ac, which is 16k squared minus 16k squared, which is 0. Therefore, one real root. Is it okay for you? Yeah? Now, the most interesting one is 2n. Let's have a look at it. Minus k x squared plus 3k minus 4x plus minus 2k plus 5. Okay, let's scroll down. Right, let's see how many roots this has. Discriminant equals b squared minus 4ac. 9k squared minus 24k plus 16 minus 8k squared plus 20k when we expand. So that would be k squared minus 4k plus 16. Right? Which is k minus 2 squared. No, something's gone a bit wrong. I can feel it. Maybe it's when we're expanding. Or maybe n is not the interesting one. No, n is not interesting. I thought it was an interesting one. It's not. No, I was right. K squared minus 4k plus 16. So that's k minus 2 squared plus 12. Yeah, which is always positive. Okay. Okay. What's next now? Okay. Yeah. I can scroll down? Okay. 3z. Right, 4k plus 3 x squared plus minus 4k minus 8 x plus k plus 3. This has one real root, so discriminant is 0. So that means b squared minus 4ac should equal 0. 16k squared plus 64k plus 64 minus 16k squared. I can get it, trust me. 12 and 3 is 15, 60k plus minus 36 equals 0. Cancel, 4k, 28 is it? K equals minus 7. Huzzah.
You need to also do the k cannot equal to minus 3 over 4.
Not in this case, because you know that k is minus 7, so it's automatically not minus 3 over 4. Right. What's next now?
3s.
Same page?
Yeah.
3s. Okay. Let's give that one a go. Can I scroll down? Yep. Minus 3k plus 1 x squared plus 6k plus 6 x plus minus 3k minus 3 has one real root. So the discriminant 0. B squared minus 4ac should equal 0. 36k squared plus 72k plus 36 minus 36k squared, 9k minus 3k, 6k minus 24k plus 12, is that right? For those?
Yes. Yeah.
Not the most convincing yes.
It is.
Okay, well I suppose if I get the right answer, cancel, 72 minus 24, what's that now? And then we have, it's 48k, is it? 48k plus 48 equals 0, k equals minus 1, is that 3s? That's 3s, okay. Yes.
Please solve page 16, number 3z.
3z as well, okay.
Yeah, it says you should write it in the file the decimal points.
That's the only thing.
Answers the wrong.
Yeah, page 16, question 3z. X squared minus 6x plus 9 equals 0, 5 dt. X equals minus b plus or minus square root b squared minus 4ac. X equals 3.00000, which is 3.
So should we write 3.000 or
I accept both in the exam, but I suppose this one's a little bit safer to write in the exam. Got that? Yeah? What's next now? Oh, you're speaking for the entire class, I see. Well, perhaps. Let's see. What else? Yeah?
14, 5,
A sketchy one.
yeah.
Okay. Page 14, 5C. Okie dokie. Y equals minus x squared minus 16x minus 61. Yeah? Yeah?
I think he means Z, not C.
Yeah.
Ah, no, what he means is Z. Yeah. Isn't that what you mean? 5Z?
Yeah.
Yes, okay. Because, you know, this ain't America, so not 5Z, 5Z. Y equals minus 9x squared minus 90x minus 232. Right. The first thing I'll check is, let's check to see if this has roots. Okay, so let's just quickly check to see if this has roots. So discriminant is b squared minus 4ac. It's a triple minus, so it's minus in total. What's wrong?
Yeah, I know. Cancel out.
Yeah. Is this positive, negative, or 0? What is this? This is 810, isn't it? No, 00.
Yeah.
Minus 36 times 232. I feel like this should be positive, right? Oh no, maybe not actually. 4 would make 1,000. 36, 18, 9. Oh no, this could be negative. Well, what is it? People with calculator, person without calculator. What is this?
Minus 200.
It's a negative, is it? Yeah. Alright, so this has no real roots, so there's no point in even trying to find the roots. Yeah? Let's just go straight into completing the square. Minus 9 out. X squared plus 10x plus 232 over 9. So y equals minus 9 bracket x plus 5 squared. 232 over 9 minus 25. Hang on, let me think. No, let me do it. Make me happy. 232 over 9 minus 25, which is 175. 25, 50. Hold on. 7 over 9. Is it? 57 over 9? Now you can tell me. I'm waiting for confirmation on this. It is. You're not just saying that to make me feel good. You really checked it.
I haven't checked out the calculator.
No, you're trusting me. Don't trust me.
No,
Definitely don't trust me.
It's mine.
Has someone confirmed that it is 57 over 9? You guys are very slow on your calculators.
I'm getting 19 over 3.
Oh yes, 57 over 9 can be simplified. 19 over 3, isn't it? Yeah, 19 over 3. So it is 57 over 9 then. So that would be y equals minus 9x plus 5 squared plus 57. Sorry, minus 57. Oh, I was just checking that this number was right. Because I did it in my head, so I wasn't sure. Okay, where's the vertex here? Where does it cross the y-axis, actually?
I think you made an error.
Where?
Because 232 over 9 minus 25 is 7 over 9.
Not 57 over 9.
Yeah, it's 7 over 9.
Okay, well, why did it take so long to fix this?
Because I was confused.
Can I borrow that actually? Because I don't trust anyone now.
Yeah, I'm getting 7 over 9 on my calculator.
Oh yeah, it is 7 over 9. It's not 175, it's 225.
7 over 9, thank you. We made the same mistake, I guess. 7 over 9, so that's a 7. But that took a shocking amount of time to
I was
discover.
looking at another question.
Oh, okay. Right, x here, y here. Where does it cross the y-axis? Yeah, I can't believe it either. Minus 332. And where's the vertex?
Minus 5.
Yeah, so like that could be like minus 5, that could be like minus 7. And actually its shape would be like, whoa, like this. It's upside down because of this guy. Minus, yeah. Right. Okay, what's next? Next? Yeah?
Page 12C.
C.
And page 12, page 12, 5C.
5C. Okay. Right. Y equals 7x squared plus bx plus c. Now, we're told it crosses the y-axis at 24. So that means when x is 0, y should be 24. Which means c has to be 24. No choice about it. Yeah? Now, the vertex is supposed to happen when x is 2. The vertex should be when x is 2. So let's see where the vertex is. Well, let's complete the square. X squared plus b over 7x, what's that, plus 24 over 7. That's equal to 7 x plus b over 14 squared plus something. Yeah. But the vertex is supposed to happen at 2. So that means this piece here, when x equals minus b over 14 to get the vertex, that's supposed to equal 2. So it means that b must be minus 28. And there is another way to do this, which a student did in the previous class, which I'll show you in a moment. It's another way to think about it.
And the example we write like just something like
Yeah, because the remaining piece is completely unnecessary. Well, maybe not write blah, write like dot 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 or something. Got this? So I'll show you another way to do it now. Yeah. Got this up the front? Got it? Yeah. Okay. The other way to do it. So the other way to do this is to, let's see. you know that the answer will look something like this. It will have to have a 9 here and a bracket. Now why, not 9, what were we doing? 7. Now, why am I saying it'll have to look like this in the answer? Well, because we know that we're supposed to get 7x squared. Yeah? And we know that this should be minus 2. Why do we know that this should be minus 2? Well, because I said the vertex is 2. And we could even work out what the last piece should be. Where should it cross the y-axis? It should cross at 24. And what is x when y is 24? X should be 0. So if I put 0 in this, what do I get? Minus 2 squared? 4 times 7? 28. And what should I get? 24. So it's a little bit too big, so I need to have a minus 4 here. Yeah?
So it's the difference between
So trial and error.
Not really trial and error. You really think about the vertex and the intercept, and you think about what numbers you will need to have in this quadratic to match up with this. And you just do it bit by bit slowly. So I knew there had to be a 7, because I'm looking to get 7x squared. I knew that this should be a minus 2, because I'm looking for a vertex at 2. And I knew this needs to be minus 4, because the total here should be 24 when x is 0. Now if I expand this, I'll get 7x squared minus 28x and plus 24. And my question is 7x squared plus bx plus c. So I can see that the b is minus 28 and the c is 24. And there's another way to think about it. Yeah, well, it depends what you mean by smart. It depends how comfortable you are with mental arithmetic. Yeah. It does require more care though. Yeah.
18,
3p. 3 what? T. I shall say request denied. I think I've done enough of these ones. How many have I done of these?
No, but the thing is, I want one where all the ones that you have done is with one distinct.
Oh, I see. You want one with 2 roots. Yeah, okay, fair enough. All right. Request granted then. 3t. So page 18, 3t. So that's 2k minus 3x squared plus 8k minus 2x plus 8k. What the heck is that? 8k plus 3. Okay, how many real roots does this have? 2. So discriminant greater than 0. Yeah? B squared minus 4ac should be positive, right? 64k squared minus 32k plus 4, 64k squared, 6 minus 24, isn't it? Minus 18, 30, minus 72? Minus not, plus 36 should be positive. They cancel. Minus 104k. Yeah? No, something's gone a bit wrong, hasn't it? Is that right? Plus 40? Okay. Should be bigger than or equal to 0. Is my answer a fraction? No, it's not. I've done something wrong here. One of my numbers is wrong. Which one? 64, 4, 16, 32, plus 4 is right. 2 times 8 is 16. 16 times 4 is 64 with a minus. 6 minus 24 is minus 18, isn't it? Times minus is a plus. That's a 72. So that's minus 32 plus 72. 40. Yeah, okay, sorry. So that's minus 40k plus 40. Yeah. Plus 40? Yeah, and minus 40k. Oh, sorry. Plus 40k. So you have 40k plus 40 bigger than 0. So yeah, 40k is bigger than minus 40. So k is bigger than minus 1. But from this we know something about k. K is not what? 3 over 2. Now I can't say k is bigger than minus 1 because there's a value of k I'm not supposed to use. So I need to qualify my answer. I need to say k is bigger than minus 1 and k is not 3 over 2. So in other words, anything bigger than minus 1 but not excluding 3 over 2. So this is technically the full answer here. Yeah?
So whenever we would have, for example, like 2 distinct truths.
Did you snap your fingers actually?
What?
Oh no, go on.
So whenever we would have 2 distinct truths or 0 real roots, we would also have to check whether it fits in within the quadratic.
Yeah, because if you get an answer that says something like k is bigger than a number, and there's a number you're not supposed to use that's also bigger, you need to say use everything except that. Yeah? Okay? Yeah? What would happen if we did use 3 over 2? We would get 0x squared, yeah? Yeah, I mean, what would happen if we used 3 over 2? It turned to linear. I'm just wondering what linear we would get. 8, that's 12 minus 2, 10, isn't it? And then 12 plus 3, 15. So you get x would equal minus 3 over 2. So you'd have one root. And what are we looking for? We're looking for 2 roots. So actually, if you did use that, you would have an equation with 1 solution, not 2. So that's another reason for not allowing that in our answer. Yeah? Are you checking it on the graphing calculator? But for what value of k? 3 over 2?
2, yeah.
And it's a linear?
Yeah, linear.
Linear, yeah. Crossing that 15, yeah.
So couldn't you just say whenever we have one root, instead of like solving for it, couldn't we just do what we just did here and find what k is equal to? You know what I mean? Like for example with O, couldn't we just say k is equal to 3 over minus 4?
In O?
In O, for example.
K equals 3 over 4. Well, k is not 3 over 4, yeah.
3 over minus, yeah.
Yeah.
Couldn't you just say that would result in one distinct root? Didn't it result in one distinct root of k?
Well, not necessarily, because I think there's a couple of examples where if you try to make the first term 0, you'll make the other term 0 as well. So you don't actually get one root, you get no roots. You know what I'm saying? Like if I wrote this down, if I wrote down k minus 1 x squared plus 2k minus 2x plus 3k minus 3. When will I make this linear? For what value of k? When k is equal to 1. And how many solutions does a linear have? One. So it feels like if I say make this have one solution, you could say k equals 1. But if you'd said k equals 1 here, what equation would you get?
These are constants.
Yeah. You get 0. Well, let me change it. Let me change it a little bit. Let me say plus 3 instead. So what would you get? You would get 6. When does 6 equal 0? Yeah, in Bizarro land, not here. So it has no solutions. So it's sometimes useful, sometimes not. It depends on the quadratic.
So when we have roots, we have to mention what it's not equal to as well, right? So if we have one root, we have to mention that, let's say for example, k, we found out that k is equal to -5. We have to say that it can't be also for...
No, not necessary, because if you're saying k equals -5 makes one root, it's automatically not... K can't be the other thing if you're saying k is -5. It only arises when we have an inequality. You know, because if I said k is bigger than -6, then you would need to also say k is not some other thing. You know?
So
Yeah.
what we're saying will only apply when we have 2 real roots or no real roots.
Yeah. We only have to really consider it then. There might be some weird situation where we have to consider it when there's one real root. You know, I could imagine a situation where the value of k that... Actually, no, there is one here, where the value of k that you get for one real root is a value of k you're not allowed to use.
That's the one that you just did, isn't it?
No. I'll tell you which one if you want to try it. It's 3n. If you want to try this at home, that's an interesting one. So what happens in 3n is when you do it, you get the following answer. K equals 1. And then when you look at the equation, you realize that's a problem. Can't be 1. Therefore, it's impossible for equation 3n to have one real root. It either has 2 roots or no roots, but it can't have one root.
But saying this has the question is saying...
The question says, what value of k makes this have one real root? And what I'm saying is, no value of k can do that. Look at the answer I wrote at the back for 3n.
When that position was replaced with this minus 2, which is...
Huh? Oh, sorry, I meant to say, sorry. I meant to say minus 1.
Oh.
Yeah. Do you see my answer?
Yeah.
Troll. Yes, correct. No answer. The only answer is excluded because the quadratic would become linear. And not only would it become linear, it's actually worse than that. It becomes a linear with no answer. It's a horizontal line.
Yeah, like y is equal to minus 5, which is 14.
Yeah, it's a constant.
Yeah.
14, yeah, which is never 0. Yeah. That's a tricky one, that one, 3n. Okay, we have a double class in a few minutes, so you can take a little bit of a break before everyone else comes back.